Okay, rolling.
This is one of the control cables coming to and from the Emu Totem site back to the Master Control Centre. You can see it's about a 12 pair cable. This was typically used for telephone and data communications. Data was only sort of DC voltages coming backwards and forwards.
This was done in the 50s. PVC was how?
PVC's been around a long time.
Been around a long time?
Yeah.
Would have been in use then?
Yeah, PVC would have been.
After the war.
HD, polyethylene was a war material, but this is sort of 8 years after the war anyway, so it's relatively modern technology. PVC is an old material. Yes, PVC. See how the way you scratch it?
Yeah.
It's PVC. I'm talking waffle now.
But it's still pretty tight. It's still pretty good condition.
Yeah, this cable would last. If this were installed in a power system, it would last forever.
Mm.
Then stuff like this went out to camera sites. They had to measure a whole lot of voltages that were going on at the atom bombs. UR1, this cable, Uni Radio Cable 1.
Well, I'm going to talk about it.
When you're ready.
Rolling.
This cable here is a coaxial cable capable of transmitting a very wide bandwidth for high-speed data collection of the radiation flux from the explosion. Further back towards the explosions from here, they had some apparatus to detect the radiation flux, and this information was sent up via this coaxial cable, which is a low-loss cable, so it had a wide bandwidth. And at this recording point behind me here, they had spiral traced oscilloscopes that were being movie cameraed, so they could find out the timing and whatever of the radiation flux from the explosions. And there would have been two coaxial cables coming from the explosion point to here. I can see that they were actually called Uni Radio 1 cable, as I recall, and I know they're an aluminium sheath cable, and it looks like there's a copper centre to the cable, and it looks like it's polyethylene insulated. So it's a very good cable, probably similar to LDF 450 these days, to an Andrews cable. It's got a PVC wrapping on it, and then beyond that it looks like it's got some kind of a I don't know, hessian-y or plasticky serving on top of that. My feet are in the road. I've only read about this cable. I've read in one spot where it had an aluminium sheath on it, but I've been unable to find any data on any of these old Uni radio cables of this particular type. Some radios, some RSGB handbooks carry some. Okay.
So we're actually rolling now.
Okay. You can see here a Mustang aircraft battery from one of the aircraft, the furthest most aircraft no doubt, that was tested at the EMU atomic tests. We can see it's a 28 volt battery, and I can recognise the pattern from aircraft catalogues that it's obviously a fighter aircraft starter battery. Oh, 500 pounds. 500 pounds. There are two Mustangs tied down, I think about 4,900 feet and 5,100 feet, as I recall, from an explosion point from Totem 1. And the Mustang's tail and wingtips were marked by steel pipes driven into the ground, according to the archives. And I can see here a steel pipe driven into the ground, and just over there, the other side of those anchor blocks, there's another steel pipe we can find. And the aircraft were anchored down with concrete blocks. As I recall, they weigh about 500 pounds, without having my files in front of me, and tied down according to an Air Force anchor pattern drawing number, whatever it was, X, Y, Z, whatever.
And you just cut it off with an anchor.
You think you'd use a rope actually, rather than that, wouldn't you? It could be from something else.
I might have thought it would burn
the furthest most Mustang, the one at 5,100 feet, was recovered and got going on site and flown out of here to Coober Pedy. Go ahead. This is a piece of the canopy, cockpit canopy of a Mustang aircraft. You can see it's curved. At 7 o'clock on the morning of the 15th of October 1953, the first atomic bomb let off on Australian soil exploded just above me at this point here at Totem 1. The explosion was approximately 91 feet above ground level on a tower that was just a few inches over 100 feet tall. The bottom legs of the tower are about, as I recall, about 26 feet long and of 1¼ by 8-inch angle iron, welded to some steel plates here, and they're set in 6-foot cube concrete anchor blocks. You can see the steel plates bent out and the bolts are bent out away from the direction of the explosion. There would have been a massive pressure wave came straight down, and the pressure wave would have been more intense in the centre, so it's blown these things radially outwards. So contrary to the idea that everything gets vaporised, quite plainly the thing isn't vaporised at all. It's just the tower's just blown away, and the bits of the steel will be perhaps hundreds of metres or more from here, whereas perhaps the top part of it would have been vaporised. This is a bit of the Collis railway line track. It's 19-inch gauge railway that the bomb was wheeled out underneath the tower. Them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 or 21. There might be another group over there too. Well, that would have been expensive cable on a stage. So a smart person could work out the order of time response they're looking at, you know, from the attenuation characteristics of these cables.
Yeah.
I've got to try and mimic you now and act like you're on the sunny side. This is probably where they intended to separate them, actually.
Ah, that's in quite good condition, isn't it?
Hmm. Well, here we have some coaxial cable connectors from 1953 in the English uni radio cable system. They're not American cables, but looks like equivalent of RG213. And you can see the rubber seal still intact, and the connector looks perfectly clean inside. It would still be working today, I'm confident.
Put it together.
I'll get my glasses on.
Oh,
There's
that's
that.
good.
Good as I bought one. They disappear again. Why do they cut and restart so often? Get around the area.
Yeah,
So the rest of hen station's run has probably done him some good.
yeah.
Right behind me is the location where the atomic tests were let off. The spot we're filming from is camera site B. And camera site B was the main camera site. It had about a 50-foot camera tower, scaffold camera tower, with 2 layers of cameras on it, with multiple cameras along benches along each layer. And most of all, they had a special Kerr cell camera. Now the Kerr cell camera could take ultra high speed movies. The exposure on slow was 1/millionth of a second, and on fast it was 1/20 of a second. It was electronically controlled by photoelectric cells, and it worked by using polarizing filters that were electronically controlled. And the Kerr cell camera took a photograph about every 3/millionth of a second, and the idea of it was to watch the shape of the expanding atomic bomb fireball to see whether it was asymmetrical or symmetrical or whatever. So that was very important in plotting the growth of the fireball with time. Also, too, scientists had theories on the way the fireball should expand at the different laws in radiation thermodynamics should govern the rate of expansion. There were several distinct phases in the way the fireball would expand. There were many, on this site there were many Nissan huts. There was electrical power articulation and power poles here. The Nissan huts had facilities for, apart from controlling the Kersel camera, which it weighed 1.5 tonnes and it sat on a tripod. There were also photographic development things. Each hut was air conditioned. There